What's up, everybody? We're out here at night again, working on the car. I'm excited to knock this thing out. We got the intake tubing completely finished. I wanted to do a video on some and touch some things on the mass air sensor and give a little bit of an update on the car. So we got this tube all finished up. This is the intake tube to the intake. We had this piece on. This is for our idle air control, and we're gonna polish that up probably and make it look really good. Honestly, not too concerned with how it looks as long as it holds boost pressure and works correctly. This is our intake tube from the intercooler up to the fender, and this will actually attach to this piece, so that goes from the intercooler into the intake, which is pretty sweet. I was pretty proud of this piece. I think the other one, too steep of an angle on the straight piece, and it wouldn't fit the fender liner, so the fender liner wanted to be, you know, somewhere like right here. So it was actually pressing into the fender liner, and I would have had to have either cut the fender liner out or remove it completely, which I don't want to do at all. I really hate taking out aspects of the car like that just because a pipe doesn't fit correctly. And then also, when I got this kit, if you can see right here, that I didn't know what that was for. I thought maybe the way this tube was integrated into the system, maybe it was to clearance something, but it's not. That's actually where the tire was rubbing, and you can see where they actually dabbed a weld into there. I think it poked a hole in it, and then they painted it. So that's kind of what you deal with when you buy used parts sometimes, and that's what we had going on this pipe, which is no good. So the reason this pipe was angled the way it was is because the air filter, which I'll get real fast, just a second. Air filter coming out of the fender, so the supercharger kind of sits up here and it comes out, and then this comes in to the engine bay behind it, and the air filter actually sits about right here. So if you took this straight pipe and angled it up and then turned it so that you would reach you know, where you needed to go, like let's say you took this angle to it instead of going underneath, then it would have made contact with the air filter, and that's no good. This air filter is super dirty. It's disgusting. So anyway, it had to go around that. So that's why it was angled the way it was, and then it also just didn't fit because it was obviously rubbing on the tire. So that pipe is completely useless. We don't care about that. So this thing fits perfect, optimal design. It doesn't really look that pretty, but honestly, it's not what I'm concerned about. So now let's get back into the real purpose of this video, the mass air sensor. So the mass air sensor on a system, you want to get it in a pretty straight part of the intake system. You know, you want a couple inches, about 5 or 6 inches on each side of it, that's straight, so that the air coming through stays nice and smooth. When air's coming through a bend like this, air has weight. So when you've got a lot of speed and air coming flying through this tube, it's going to build high pressure on this outside section. So it would actually read more air on that section than it would right here. Well, the higher the velocity of the air, the more pressure it's going to build on that outside corner. So if your mass air sensor is like right here or right here, it's going to see more air. Well, when it comes down off of the velocity of air coming through, like you're idling or something like that, it's going to be less of a difference between both sides. And then as you increase it, that pressure is slowly going to increase on this side, and you'll slowly watch more and more air build up on this corner as it tries to make that turn. So after it makes that turn, it straightens back out, and then that's what we're dealing with right here. And then also, you don't want it on a sharp turn or a sharp bend on the top, because you can have issues there. They're honestly super minor issues, not something that's gonna like really get in the way of the car too much. But again, optimal position for a mass air sensor is in one of the straightest points in the intake system. So that's where this is. It's gonna sit really nice. I don't think I'm gonna need an extension harness to reach this. It is kind of under the fender, but we'll see how well that works. And then onto how a mass air sensor works. You're reading air as it comes through, obviously, and it sends a signal to the computer, you know, based on how much air it reads. And the way it reads air is a heated wire. If you look up mass air, I'm not going to go into the science of how the mass air sensor works particularly. If you just Google mass air sensors and how they work, you can read up on them. It's pretty fast, you know, easy information to find. But what I wanted to go over on this is different tube diameters. So if you took this mass air sensor that was basically calibrated for a certain diameter tube, this is 3-inch, and you put it in a 3.5-inch tube, it's not going to read correctly. You'll probably just stall out, won't even idle. Well, why is that? Why is a mass air sensor not like different tubes? That's why they sell them in the 90mm or the different like size tubes. Most of the time it's a 90mm tube, which is a 3.5-inch, which is about this size right here. So that's usually what you'll buy a mass air sensor in, and it always comes in a housing. And the reason being is because the mass air sensor has a transfer function based on how much air is coming through. So this is our tube. We'll pretend we have a mass air sensor in here. What the mass air sensor is doing is it's reading air as it hits that wire. Well, it's only going to read air in like one spot. So the way the tuning system works is SCT, for example, when you buy their tuning software, they give you some extra what are called value files. And those value files have values in them that you can import into your tune based on different changes you make. So you have, injector calibration value files. So it's like, all right, I'm using a Ford Racing injectors. You literally can just copy paste Ford Racing injectors from a value file and calibrate it into the tune, drop it into the tune, and it's supposed to be the correct values for those injectors. So if I go in there, I'll have a BA3000 SCT big air mass air transfer function value file. I can take that, I can import it into the tune. Well, if that value file is written for a 90 millimeter tube, it's not going to work in my tune. And the reason being is because the way to think about it is a mass air sensor is basically a guy standing on the side of the road, and he's watching cars go by, and he's on a 2-lane road. So every time one car goes by, he can only see the 1 lane, but he knows it's a 2-lane road. So every time one car goes by, he knows 2 cars went by. So he tells the computer, hey, 2 cars just went by. All right, sweet. 2 cars go by at a certain pace, 1, 2, 3, 4, 5. He's telling the computer how many cars are going by. Well, if you put it in a bigger tube, you basically put more lanes on the highway. So now every time 1 car goes by, 3 cars just went by. But he's telling the computer that only 2 cars went by because he's visualizing it as a 2-lane road. He's visualizing it as a 3-inch pipe, not a 3.5-inch pipe, or vice versa. 3.5-inch pipe going to a 3-inch pipe. He's telling it's got three cars just went by when 2 cars went by. Same thing with basically your air molecules. Every time one goes by, it's telling it a certain amount is going by. So when it sees a certain volume of air coming through the tube, it has to be the transfer function written for that particular tube size. And the way to get around that, the way to work with that is you go into the tune and you adjust the mass air transfer function, which it's very much what it says it is. It's a transfer function. When it sees a certain signal, it sends that signal to the computer, and the computer looks at a table and says, okay, at this signal, this is how much air is coming in, and it makes calculations all off of that. The mass air transfer function is the single most important value that's going to be in the tune. It's everything. It's because the reason it's so important is that's actually your load calculation. So that's why you can take a mass air sensor system and add air or take away air, make some changes, and it'll actually tune for those changes because it's reading how much air is passing through this tube. If it's passing through this tube, that engine's going to ingest it, and it knows, okay, there's 8 cylinders, this amount of air went through the system, it divides it up into 8 cylinders, and it knows how much air is actually reaching each cylinder. Whereas on a map system or a system that uses speed density, you have a VE table that you set up, and you are basically building the load calculation into the VE table. Whereas this one, this is the load calculation. It does everything from here, and it's everything's based on top of that. It's literally the bottom of the equation. So if that is wrong, your fueling will be wrong, your ignition timing will be wrong, everything will be wrong if this is wrong. That is a very, very, very important piece to get right. If you get that wrong, it's just going to run like shit. So that's why if you change intake systems and stuff, that's what you're having to tune for is the different air amounts that are coming through the tube that you just changed. You have to tell the computer and make it more accurate. So that's how your mass air system works, and that's why I integrated it into this particular part of the intake. I'm going to go in, and like I said, I have value files for the BA3000, but I'm like 95% sure it's for a 3.5-inch pipe. So I'm probably going to have to make a guess calculation and do my low end of the load table in the transfer function off of just kind of doing some math and putting it in there myself and hoping it's right, and then hoping it fires up. And when it fires up, I'll get it to basically run good at revving up to like 2,500, 3,000 RPMs, And if I can keep it stable through that, then I'll take whatever I change those values to, and then take the rest of the mass air transfer function and change the rest of it to whatever percentage change I put on the bottom half of it, up to like 3,000 RPMs. And then when I do that, it'll at least probably drive. And then we'll go over to the dyno, and then that's when I'll get on the dyno and I'll do actually some steady state tuning, which I can talk about in a different video, and then some other actual dyno tuning strategies there to get it all done. This thing will work. And here's the other thing I was going to mention. This SCT BA3000, it's rated for 800 horsepower. So let's say, oh man, I'm looking for a car, I'm going to pump a bunch of boost through it, I'm going to make over or around 800 horsepower, I'm going to get this sensor. And you take this sensor that's rated for 800 horsepower and you stab it in a 3-inch tube. When they rated the horsepower rating, they were reading it off of a 3.5-inch tube. So what that does is it limits the amount of horsepower that this thing will be able to read, because the diameter of your tube, if this thing pegs out at, let's say, you know, such and such CFM on this tube, well, that's going to be less than it pegging out on this tube, because this tube can ingest more without running the mass air sensor to its peak. So I'll say that again one more time in a different way so that it's a little easier to understand, because I know that's kind of weird. But again, this is an electronic signal coming from this. That's all it's going to be doing. There's no brains in here really. It's taking a signal and it's saying, all right, it's requiring this much voltage or whatever to run this wire at a certain temperature, and it sends that signal to the computer. You will max out that sensor in a smaller tube before you max it out in a bigger tube, because the air passing through it, let's go back to the car analogy on the highway. If it can only read at, let's say, 5 cars a second, well, if you have it in a small tube, it's reading 10 cars a second, and that's as far as it can go, because that's the fastest it can read air coming through. Well, if you have it in this tube, you add an extra lane, and now you're reading, 15 cars a second. So you can more accurately hit a higher number in a larger diameter tube than you can in the smaller tube with the same mass air sensor. So that's something important to realize. This one's gonna work perfect for me because I don't need 800 horsepower, I need about 500 horsepower. This tube's gonna work perfect for me, and I really like where this is going. And then the other cool thing that I did while putting this thing together is we actually installed a NTP fitting for the Nitrous system. So now there's no like attachment or O-ring or anything to get the Nitrous system in, because this is going to see boost pressure, so this has to seal against whatever boost pressure we're going to be running. So I just installed that. This is our Nitrous nozzle, and I will put some thread tape on that, and then it screws in, and then bam, it's right there ready to go, installed right into the intake, built for it, literally built for Nitrous. So that's super cool. We're still running the universal dry shot, and I'm going to spray the mass air sensor just like I was before. A lot of people don't like doing it that way. A lot of tuners don't like that, but it has yielded good results for me in my last setup. So I'm going to do it on this just to see if I can make it work. And if it does, I'm super excited about that. And we're only going to be running like a 50 shot on it. But again, I'd be comfortable pumping it up to 100, 150 shot, but I don't think the motor would be comfortable with that. So until we get to that point, this is the system we're going to be running. Like I said, we'll probably see with the setup I've got on the car and the pulley ratio I have on the car, maybe 8 to 10 pounds of boost, hoping mid to high 400 horsepower. And then we'll be spraying it with a 50 shot of nitrous. I'll probably see just over 500 horsepower and probably high 400 foot-pounds of torque. And that's pretty much it. Tonight I'm gonna work on putting this boost gauge in the car because the intake is done. Done. That's a big deal for me. I'm very excited about it. But anyway, yeah, very excited about the intake. So today, now that the intake's done and I'm kind of waiting on some things for that, we are going to install this. I tried to stay away from the A-pillar gauge pod thing, so we're gonna install it with the this one here and put it on the steering wheel. So that's gonna look cool. I have one of these on another car. I love it. I use my air-fuel ratio in there, but in this car, the air-fuel ratio is where the CD player and radio used to be, because I don't need those amenities. I am beyond such things. I'm just kidding. I wish I had it. I actually might install a Bluetooth radio where you don't even see the radio. It'll be like under the seat or something, and I can control it from my phone and play all my music through a Bluetooth system, and that way you don't even see the radio anymore, but you still get sound. So that's gonna be actually probably where I go with that, which I would be pretty stoked about. But that's pretty much a good little update on the intake system and what we're doing with this piping and how we're going to run all this. And thanks for watching. I hope to catch you next time.